Hi future doctors, welcome to the next class. In this class, we will discuss about one problem on center of mass. If four masses are placed at four corners, four masses placed at four corners of a parallelogram which is making an angle theta. So, which is going to be A one side, another side is going to be parallelogram. Parallelogram means opposite sides are going to be same. So, angle between any two sides is going to be theta. Then find the position of center of mass of these four mass particles. So, for this how we will calculate means, so this is going to be y axis, this is going to be x axis, correct? So, you have to find coordinates, isn't it? X axis, y axis, and where is the position? What are the positions of all these mass particles? Let us assume this is m1. m1 is going to be m. It is at origin 0, comma 0. Next, m2. Second mass you can take this. m2 is m. x2, comma y2 is. So what is this x2 means? B. It is on x-axis, therefore y2 is 0. Next, m3. m3 is going to be m. x3, comma y3. So what is x3, comma y3 means? This is going to be y3. This is going to be x3. Correct? Now what is y3 and what is x3 from the diagram means, if you are taking this is a theta is making, then x3 is a cos theta, which is basing theta, that is a cos theta. So remaining, this is going to be a sin theta. Therefore y3 is going to be a sin theta. So therefore a cos theta, comma a sin theta. Next, m4 is going to be m. Then x4, comma y4. x4, comma y4 is equal to. So what is x4 means? From origin to here. So this is going to be x4. But already we came to know from here to here. Let us assume A, B, C, D. We came to know OC. What is OC means here? B. We should come to know CD to find x4. Now how we are going to get means, again if you are taking this is A, if you resolve this, because parallel sides are going to be, angles are going to be same. This is going to be, this part is going to be A cos theta. Again this one will be A sin theta. So therefore CD, x4 is equal to OC plus CD. OC plus CD. What is OC? B plus A cos theta. Therefore, B plus A cos theta, comma, what is Y4? Y4 is going to be A sin theta. So, once you found all these coordinates, then our formula x equal to, so m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4. What is m1? All m's are same. M into what is x1? 0 plus m into b. Next, m into what is x3? A cos theta plus m into what is x4? B plus A cos theta divided by 4m. So all m's will be cancelled. So if you have written this, b plus a cos theta plus b plus a cos theta divided by 4. So how many b's are there? 2b plus 2a cos theta by 4. So b plus a cos theta by 2. This is going to be xc. Now what is yc? So if you want to calculate yc, so what is the formula for yc? Yc is equal to m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 divided by m1 plus m2 plus m3 plus m. So m into what is y1? 0 plus m into what is y2? 0. So plus m into what is y3? A sin theta plus m into again a sin divided by 4m. Then what you are going to get means this is 0, 0, a sin theta plus a sin theta. So 2a sin theta by 4m. So m will be cancelled. Therefore, a sin theta by 2. So xc is b plus a cos theta by 2. Yc is a sin theta by 2. This is position of center of mass of these four particles placed at four corners of parallelogram. Next we will see distribution of mass. Mass distribution. How mass is going to be distributed on any object. If you are taking a wire, so linear wire we are going to say, it is having L length. Now what is the mass contained in this L length? That is going to be M. So the amount of mass per unit length is called linear mass density. Linear mass density. So if you are taking small amount of portion on this dl, on this small amount of portion, small amount of mass is there at the time. So dm by dl. So if you want to calculate total mass, if they give small amount of mass, small amount of length, this formula we are going to use, because lambda is same for the small amount of portion or big amount of portion. This is like apple problem. One apple 10 rupees, 10 apples how much? For dm length, for dm mass, dl length, then for total length, how much mass? If you cross multiply, you are going to get. So wire is having length, there is no area. Therefore, on this length, how mass is going to be distributed, mass particles. That is only linear mass density. What is the unit for this? Kg per meter. Dimension formula, kg means m, length means L. So m L power minus 1. This is the dimension formula for linear mass density. Who will be having this linear mass density means wire. Wire which is having less area of cross section, only length. Next, if you are taking a thin paper in a book, if you are taking one paper, the paper is having only. So if this is the paper means this paper is having only area. So within this area, how much mass is going to be available? So mass per unit area. This is only surface mass density. So sigma equal to m by a. So if you are taking small portion on this, dA dm, then dm by dA. So units kg per meter square, m by L square. Surface mass density. Who is having surface mass density means which is having only area. So like thin paper. So if it is having volume, like book, box, anything if you can take, if it is having volume. So within that volume, how much mass is going to be available? This one only everyone came to know as density, but that is volume mass density, linear mass density, surface mass density or surface density they are going to call. So kg per meter cube. For small amount of volume, so dm by dv. How mass is going to be distributed on the objects we have to take. But later they remove that volume mass density. We are calling this one as only density. So total name, full name if you want to read this one. So volume mass density. Rho is equal to m by v. So these you should come to know for next upcoming problems. Then only we can get very easily we can understand, because mass can be replaced with This lambda and L or sigma and A, otherwise rho and V. This is about distribution of mass.